Which biomarkers are associated with Alzheimer's disease? To address that, let's take a look at a recently published study that included almost 326,000 people. In that study, the average age was 56 years, and then there was a 9-year follow-up. In other words, starting with the baseline biomarker assessment, what was the risk for being diagnosed with Alzheimer's disease up to 9 years later? So let's start off with the obvious, metabolic biomarkers, metabolic health. On the y-axis, we've got 4 of them: glycated hemoglobin, total cholesterol, triglycerides, and serum glucose. And on the x-axis, we've got the hazard ratio per a 1 standard deviation increase for Alzheimer's disease. In other words, Alzheimer's disease incident risk. In terms of what's significant, we put up a red line at a hazard ratio of 1. And then when the data is completely above 1, when the 95% confidence interval, that's the horizontal line to the left and right of each of the 3 shapes in green, blue, and red. When that's completely above 1, we have a significant association. In other words, higher levels of the biomarker are associated with an increased Alzheimer's disease incident risk. Conversely, to the left of a hazard ratio of 1, if the 95% confidence interval is completely below 1, in that case, higher levels of the biomarker would be associated with a lower incident risk for being diagnosed with Alzheimer's disease. All right, so on to the data. So we've got 3 models. First is age and sex adjusted. The second is the multivariate model, but the third, which is the one that I'm most interested in, is the disease-specific model, which includes adjustment for as many factors as possible that can impact the association for blood biomarkers with Alzheimer's disease incident risk. All right, so first, serum glucose, not associated with Alzheimer's disease incident risk. We can see that its confidence interval completely overlaps with that hazard ratio of 1. Similarly, glycated hemoglobin, HbA1c, overlaps with 1. Total cholesterol is just on the borderline of significance. We can see that the right side of its confidence interval is just barely overlapping with that hazard ratio of 1, which would suggest, if it were significant, that relatively higher total cholesterol in this study was associated with a lower incident risk for being diagnosed with Alzheimer's. But the most interesting of these 4 is triglycerides. In this case, relatively higher triglycerides were associated with a lower incident risk for being diagnosed with Alzheimer's disease. And if you saw my earlier video on longevity-associated triglycerides, not all triglycerides are the same in terms of which fatty acids that they include. And there are some triglyceride subspecies that are associated with a greater odds of reaching 85 years. Whether that's a part of the story, I don't know, but I'll look more into this story in future videos. So from these 4 biomarkers, we can see that relatively higher triglycerides are associated with a lower Alzheimer's disease incident risk. All right, so moving on, inflammation. One marker, C-reactive protein, not associated with incident risk for being diagnosed with Alzheimer's disease. The liver biomarkers, albumin and alkaline phosphatase, similarly not significantly associated. Kidney biomarkers, blood urea nitrogen, creatinine, and uric acid. Each of these 3, not significantly associated. All right, moving on, lymphocytes. I don't know why they only focused on lymphocytes. They should have, if they had lymphocyte levels, they should have also had neutrophils and monocytes, but that data wasn't included in the paper. Nonetheless, lymphocytes not significantly associated, which then brings us to red blood cell biomarkers, including total levels of red blood cells, the red blood cell count, red blood cell distribution width, which is, if you're familiar with the channel, you know is a major predictor of Dr. Morgan Levine's biological age calculator, PhenoAge, and then the mean cell volume, so the average size or volume of a red blood cell. So these are the red blood cell biomarkers. So first, relatively higher levels of red blood cells were associated with a lower Alzheimer's disease incident risk, which may not be a surprise because red blood cells decline during aging. Conversely, mean cell volume, the red blood cell volume, or MCV, relatively higher MCV was associated with an increased Alzheimer's disease incident risk. And that too may not be a surprise because the MCV increases during aging. What is a bit of a surprise, though, is that the RDW is not significantly associated with Alzheimer's disease incident risk. So if you're using PhenoAge and think that a younger age using PhenoAge may be somewhat protective against future diagnosis of Alzheimer's disease, based on the RDW, which is, again, a major driver of Levine's PhenoAge, these data would suggest that that's not the case. It may be important to track other biomarkers, including triglycerides and the red blood cell count, which are not included on PhenoAge. All right, moving along, we've got 3 more biomarkers: systolic blood pressure, diastolic blood pressure, and waist circumference. Neither of these 3 were associated with Alzheimer's disease incident risk. And then last but not least, we've got the lung function biomarker, forced expiratory volume, or the FEV1. And here we can see that a relatively higher forced expiratory volume, so the maximal amount of air that you can forcefully expire in 1 second, relatively higher levels were associated with a lower Alzheimer's disease incident risk. So better lung function, lower AD incident risk. Now, that's potentially important. This association is potentially important because the forced expiratory volume, again, the FEV1, declines during aging. And that's what we'll see here, with the FEV1 on the y-axis plotted against age. And this is from about 10 years old to 85 years old. And then we've got two plots. On the left, we've got data for men, about 58,000 people, and about 60,000 women on the right. Two curves, top 5%, so people who had the highest FEV1, and then the median, 50%, and the curves below that. And then we've also got four curves within each of these two curves, and I'm going to focus on the data for the healthy non-smokers, because if you're interested in longevity, in my opinion, that should be the default state. So for both men and women, we can see that the FEV1 peaks at about 20 years and then declines during aging. Pretty obvious to see that age-related decline. But the good news is that it can be tracked, and by using things that we can easily purchase for relatively cheap, which is a spirometer as shown here. And I've chose to focus on this model because I wanted to identify spirometers that have been compared against spirometry at the physician's office. In other words, we don't have to go to the doctor to see what our lung function is. Now, in this study, and the link for this paper and all of the other papers will be in the video's description, in this paper, this spirometer had a 0.94 to 0.96 correlation with the FEV1 that was performed via spirometry at the doctor's office, at the physician's office. In other words, this home-based spirometer is as good or has a very strong correlation with spirometry done at the doctor's office. So we don't have to go to the doctor to do it. We can do it at home, track it ourselves. So with that in mind, what's my data? And I've been tracking the FEV1 since late 2022, September of 2022, and I have 193 independent days of data going through February of 2024. Now, a quick note before showing the data. When I do measure it on each day, it's the best of 9 trials. So essentially, it's like a 1 rep max for my FEV out of 9 attempts for my best, my best value out of those 9 attempts. I've been generally tracking it 3 days per week. And then for every test, it's exactly between 9 and 10 p.m. So I've standardized the time because who knows how later in the day or earlier in the day may affect the data. So to minimize that variability, I've focused on a very narrow time window for all of the measurements. All right, so then we've got the data as shown here. Now, when I first started tracking, it wasn't long before I decided to try to increase the FEV1 by using a lung-specific trainer aimed at offering an increased resistance above, exercise training to try to get a further boost for the FEV1 to strengthen my lung muscles that are involved in the forced expiration. But I likely overtrained because you can see I actually had a reduction for the FEV1 with all the red dots. And it's likely overtraining because once I stopped using the lung-specific trainer, we can see that my FEV1 started to increase, such that in 2023, average FEV1 over 134 different measurements, 134 different days of data, average was 3.25 liters per second. Now, we're in 2024, and so far the data is a bit better over 21 different days. Sample size is obviously smaller, so hopefully I can keep this up for the remainder of the year for the remaining 10 months. My average FEV1 thus far in 2024 is 3.38 liters per second. So how did these data compare against age-expected FEV1? So for that, we pull up the charts from before, and when looking at the median values, my age-expected FEV1 based on chronological age, I'm currently 51 years, would be 2.95 liters. So I'm doing a little bit better. More specifically, the 3.25 liters per second for my 2023 FEV1 would be the median value for someone about 10 to 11 years younger. So pretty good news. Better than age-expected FEV1. Now, the goal isn't to get to 4.5 liters, which is the top 5% for a 20-year-old. I don't know if I've ever had values that high. But for certain, though, is to avoid the age-related decline. And because I'm tracking it 3 days per week, if I start to see any dip over a few weeks or longer, then the goal is to go back to the lung-specific trainer and optimize the duration and frequency that I'm using it so that I'm not overtrained and I can get a small increase to resist that age-related decline. All right, that's all for now. If you're interested in more about my attempts to biohack aging, check us out on Patreon. And before you go, we've got a whole bunch of discount links that you may be interested in, including discount links for epigenetic testing, oral microbiome composition, NAD quantification, at-home metabolomics, at-home blood testing with SciFox Health, which includes ApoB, green tea, diet tracking with Chronometer, or if you'd like to support the channel, you can do that with the website Buy Me a Coffee. We've also got merch, so if you're interested in wearing the ConquerAging or Diet Trying brand, as I've got on here, that link and all of the other links will be in the video's description. Thanks for watching. I hope that you enjoyed the video. Have a great day.